Hello.
Welcome back.
Welcome back. Thank you for coming back. So we'll go ahead and start with part 2 of the presentation. Let me just 1 second here. Okay. All right. This is not working anymore. What the hell is going on?
I think you can just do the arrows.
Okay, it's fine. Focus problem. All right. So we just wanted to take a little step back and look at the history of the project from the beginning. I mean, we won't go in very much detail, but this is just to get a little overview of how it started and what happened, and what got us here. So initially, I was part of the symphony core team or something. Well, there was no core team back then, but I was doing things on symphony. And Nils was the lead developer of PHP-BB, and PHP-BB was looking to use symphony components as well, so they were showing up at the symphony conferences, and so we started talking then, and both of these projects needed a plugin installer of some sort, so that's how we kind of got started. Hello.
That's no problem.
So we got started there in February or so. Was the Symphony Live conference back then in February 2011, and then in April was the first commit of the composer repository. Then we had a few months until September where we published packages.org, and at that point you could actually submit the first package. So Monologue was the first package number 1 in the database, which thankfully is still running. Then a year after we started, we had already a first 1,000 packages submitted, which I think is kind of crazy because at that time it was still very rough around the edges. It was kind of crazy to use it in production, I think, but a lot of people already did. And I mean, 1,000 packages is already quite a lot. It's not nothing. And then a year later, we had 10,000 packages, which to me goes above anything I can think of that we would ever need. But this was 5 years ago. So, and then a few years in, I started working on torrent proxy because that was kind of a first iteration of me trying to find an income stream for kind of paying me the open source time I was spending, because I realized this was not really sustainable at some point, and I was just spending so much time on it, and I didn't, it turned into a job more than a fun thing at some point, except the job didn't pay, so that wasn't really a good job. So yeah, that was kind of a first thing I tried to get some money back into the project and kind of fund the open source development. But this didn't work so well. So 2 years later, I teamed up with Nils again to kind of work on this private packages project and do another attempt, take a bit of a different angle. And also to work with someone else is a lot more motivating, because being alone all the time on this stuff is, in the long run, it's not really working out. So yeah, we'll talk a bit more about that in details later. And so yeah, that brings us to today, where we have 185,000 packages, and that's really insane. I think, I really don't know what they all do. It's I can think of 100 packages that I think are useful, and then the rest I don't know. But it's great. I mean, it's been growing like crazy, and it's still the curves are still going up like crazy. So it's it doesn't seem like it's gonna stop anytime soon. Yeah. So that's where we are now.
Thanks. So with like this giant size of what you can possibly use, and I was kind of saying that Composer, we think of it as a dependency manager, but I kind of want to take a broader look on that and like, what does dependency management then even mean? And you can kind of see this not just with Composer, but there's like other parts of an application. And I like to break this down into, I guess, 3 main things. The first part is what I call the assembly stage. So this is kind of where you use a tool to put together your application, right? Like you run a Composer install, it puts everything together. There's the part that's actually about change management, so dependency change management, I guess, which is things like deciding to update certain packages, installing new things, deleting certain things. And then as you do this, I guess you always have certain things in mind that have to do with analyzing risks related to this. Is this update going to break something? Is adding this new dependency going to be a problem? And trying to reduce those risks. And this is kind of both, I say at the bottom, like at build or at runtime. So you can also think of this for, like using some external API, for example, is also a dependency, right? Sometimes you use Composer to maybe install the little library that works with the API, but the API itself is a dependency that you'll probably have once your application is up and running on a server somewhere. And all the same things kind of apply to that too. So yeah, assembly is kind of this installation part. So, like running a Composer install, getting all your files in place to make sure the application as a whole is ready to run. That could be, on a server, something like an apt-get install for some system package that you need. Or, running your configuration management system to get your VM into the right state or something like that. Just kind of piecing it all together. Or then on the other side for services, APIs, it's more the authenticating with the API so you can start sending requests or that little bit of code that you have to connect to the API. And then kind of at runtime, the actual, let's open an HTTP request to this thing. It's kind of assembling your application to be able to perform the tasks that it's supposed to be doing. And I kind of covered this in the first part of the talk. Which is that this big change in assembly has been going from the step-by-step installation instructions where, somebody tells you install the following extensions, make sure that your Apache is configured this and that way, and then, make sure that you install, like you download this zip file and put it in this directory of your PHP application and kind of all these manual things to a point where we try to just have one thing that describes the system state and then we have some tool like Composer that moves it into the state. Dependency change management, well, first change, as I was saying, is that the change itself is just something like removing a package, updating a package, replacing one with a different one. Same thing again with like APIs and services. Kind of what you do when you run a Composer update, when you edit your Composer JSON file. And with change management, I don't mean, if you look up change management on Wikipedia, you'll find some definition of what that is. That's not really what I'm talking about here. I'm just using this in like a colloquial way. It's kind of this process of balancing the risks. Figuring out what is the consequence of me updating this. Oh, that's going to install the following 3 new dependencies as well. Do I trust these things to be stable? Does it, choosing this new library here is only available as a development branch version. Do I want to trust that thing to be, like what we were covering earlier, to have dependencies on things that may change? Do I want to rather make sure that it's a stable version? These types of things, like what are the costs? Like, am I going to have to fix bugs a lot because of this? What are the advantages? It is going to, adding this new library going to help me solve a lot of problems, avoid, I have to program a lot less. That's really cool. But it's also about architectural decisions that then allow you to change things more easily. So things like, instead of just using a package directly, some PHP package you found on packages.org, maybe building a little wrapper library that makes it easy for you to use in the rest of your code so that you can easily replace this library with another one at a later point. Like if you decide that this thing isn't really working that well and you still have something that works on your end. So kind of this abstraction layer around a concrete service. Sorry, Mike. So going back to the history of Composer, some architectural decisions or principles that we were following is on one side that we want to build kind of separate independent tools. So this is part of the reason why we have Composer as the command line tool, packages. There's this place where you install packages from. And I think that's mostly because in the PHP world, we kind of were familiar with pair. But this is something that you've seen in, like, you know, all these other places. Like, let's say NPM in the JavaScript world, as people have heard of a lot, where people talk about all these different things using the same name. And the result of that is kind of that conversations about these tools become kind of difficult to understand. So if you're talking in the JavaScript world about NPM versus Yarn, well, Yarn still uses NPM because NPM is also this thing that NPM connects to, because it's like all these things at the same time. So it becomes kind of difficult. So that was one thing that we wanted to separate these things a bit and kind of make it easier to communicate about. And that's why packages is this entirely separate name and different thing from Composer. And we wanted to build reusable code. This mostly kind of came from the idea of making Composer a library that could actually be used to install PHPBB plugins. And while I think PHPBB, I mean, I guess at this point they're kind of getting there too. It took a lot longer than we really thought. I think, like, for example, the Contao manager is actually kind of this original idea and vision of what it should be. Yeah, like along the way, this kind of got a little more tricky and complicated than we had originally anticipated. But there is like a, yeah, good job. I mean, that is kind of the idea why, like, the whole thing is, you know, Composer is for the most part a little CLI wrapper around a large library, which you can then use to build other tools. And an effect of this is that, you know, other tools have emerged around this and services. And just our, like the ones that we actually maintain is like, if you go to github.com/composer, you'll actually see a bunch more projects and repositories in there, like little libraries that are part of what Composer is and so on. With that, I think I'll, oh, can you keep going? Okay, sorry. Like a little miscommunication here about where we switch and like, so thinking about where packages come from. So the part we skipped kind of on the first part of this talk is kind of, we have like all these versions and we install things and so on, but somehow Composer update and install get these pieces of information from somewhere. So one thing that Composer update has to do is first load all this package metadata so that it even knows what packages exist, what versions exist, and which of these require which other packages. Then it resolves these dependencies. That's like the thing that ends up using all this memory that we're kind of familiar with, mostly because there's so many, as you saw, packages and versions, and it has to kind of figure out which of these actually fit together. And then as a result, it creates the log file. And the install then downloads those files or checks them out in case of Git repositories into the respective locations. So the first thing that we kind of built, I'm trying to remember the date of that exactly. This was pretty early on when we were building Composer, just as we were trying to set up packages. We kind of figured there's got to be a way for people to run their own Composer repository. You know, like a thing like packages, but kind of something where they can put their own packages so that, you know, if they have internal packages they don't want to publish on packages.org, there's got to be a way to work with that. I guess early on we kind of also needed this for testing to a degree. Like, I don't know, it's useful to have something like that around. So we built Status. So again, try to pick a different name for this to make sure that it doesn't get confused with other things. Which is really just a static file generator, as in it generates a JSON file, one really large file, that Composer can then read from and get a list of what packages are there, what versions are there, you know, what are the URLs that I can download these things from, what are their requirements, and so on. And then it also allows you to generate the respective like zip files for a specific version from a Git repository that you've configured in there. So you kind of have the configuration file that lists all the repositories that you want to generate your packages from, and it outputs this big list that Composer can consume. But since that's really all it is like this file generator thing, like a little script that generates a file, it's not really particularly useful to kind of build more things around it. Like the most commonly I've seen when people do this is kind of like on a cron job, for example, so that just every couple minutes it'll rebuild this file or something, so that if you're making changes to your code, you want to rebuild your packages, it kind of like just does this in a loop. But what you really want is like how packages.org, for example, works, where when you create a new release, it gets pushed there automatically, and then everyone who's using these things can start using them. So that doesn't really work with this. You can't really build further tools on top of it because it's not really this kind of concept of like a service or like a library that's like very reusable. So if you actually want to build something with this that you can use to distribute your plugins or something, or if you want to use this as a team internally, you're actually going to have quite a bit of work and as such like also cost involved in getting this to run to the degree where it's like really helpful to you. So while it was kind of like a cool first thing just to have something, it's also not that great a tool. And that's why we then created private packages, which Jordi mentioned earlier, which is like twofold. So one thing, on one side, it really solves this problem of being able to run your own Composer repository and that you can store all these packages in. And on the other side, we created it so that companies that actually have a use for this, that earn their money by using Composer for their various projects, have a way of giving something back to the project and making sure that the maintenance can actually be paid for. That what is now actually kind of a full-time job for people can actually be paid for. So the way that this works is there's two versions. One is a software as a service version, so you can go to packages.com, just like packages.org, and you can set one of these up. Or there's also a on-premises version that you can run on your own servers, available on the same site. And the idea is that it makes this whole process a lot easier, so that it has integrations with all the typical things you might use like GitHub, GitLab, Bitbucket, and so on. It automatically sets up all your packages, like it finds them in there, and makes them available for you to use with Composer later on, without you having to configure a whole lot of things. Does authentication the same way that you used to, so you can log in with your regular GitHub, Bitbucket accounts, and you'll have access to the same packages as the repositories that you have in your organization. It allows you to kind of manage permissions on this fine-grained level to figure out which teams of people and so on have access to things. Kind of all those things that you're used to from other developer tools, also available for Composer. And the main thing is that we rewrote this entirely, so it works very differently from status. It's not like this generator script, but rather it's an entire application that is going to be the foundation for us building future functionality to simplify this whole dependency management process, to try and give companies that have to work with a lot of dependencies more tools to keep track of their updates, to make sure that they're on top of managing all their different applications.
All right. So I want to dive a bit more into this like loading metadata part. So we have Composer at the core. What it does is it starts by loading all these repositories, and so repositories, each one of them has a set of packages inside, and so it loads package data from all of the repositories that you make available. So by default, it only comes with packages.org as the kind of default repository, and that one is of type Composer. And then we have all these other repositories which have like different kind of uses and different usage patterns. So I just want to go through them quickly and so you see what's available. The package one is really like it allows you to install anything because you have to define the whole metadata yourself. Like it doesn't give you any automation or anything. It's just saying, here is some data, that's a package definition, and then if you require it, it gets installed and that's it. Like you define the version yourself, you define the dist and or the source. So like source is for Git or Subversion, and dist is typically a zip file or a single file even. So that lets you just, if you need to like install a set of JSON files or something that you have, or I don't know, just some random data file, for example, you could keep track of it that way.
Or some old PHP package that doesn't actually have a Composer JSON yet, so that you can actually define all this information that should be in the package yourself. You have to use the package that's just in a zip file.
Yeah. So that lets you really do anything, but it's also pretty cumbersome because you have to keep it all up to date and kind of define everything by hand. The other thing is the path repository, and that's really mostly useful for this kind of monorepo concept of having like a lot of different packages into one big repository. So that lets you, let's say, like split up your code a bit more, but still having it in one Git repository. And with the path repo, you can define like relative path like that and say, okay, like so the repo here would be like the Git repository. And you have project A and project B, and each of them is this individual package with the composer JSON and so on. And you just have the relative path to project B, and you say, okay, project A actually requires project B. And then, you know, you might have like, I don't know, a few different internal projects that rely on this like main library with all your domain logic or something like that. So this is pretty useful, and what it will do is just like create a symlink between the two. So when you edit stuff in project B, it's immediately reflected in the vendor directory of project A, and it makes working locally pretty easy. Another way is if you want to reuse your own stuff, or you know, if you need to fork some library, for example. Is to use this VCS repository. So that's what's used by packagists to keep everything in sync. So essentially, like submitting a package to packagist, all you need to do is give us the Git repo, and then the rest is done automatically. And it works exactly the same way as what this does. So this really just, you say, okay, I have this VCS repo, go fetch information. It will list all the tags, list all the branches, and then make all of these available as versions. And then this will also automatically give you dist files, so like zip files, to be able to download those, but only if you use like GitHub or Bitbucket or GitLab, because if it's just a plain Git repo somewhere, well, there's no API there to get us a zip file, so obviously we can't do it. So in case you need to fork something, like in this case, let's say we're using Symfony in our project, and you know, we find a bug and we fix it. Ideally, you kind of want to use this bug fix before like the next release, which, you know, might be in a month or two. So you really want to use your own version of the code for a little while, at least until it's been merged, and then you can go back to the mainline software. So in this case, you just define your VCS repository that way, and then, well, you can require dev master, or typically if you do like a bug fix, you're gonna have some branch. So you say, okay, the branch is called my patch, so you require dev my patch, and that will load it fine. The problem with that is that usually you have other things that require, like especially with a framework or like a CMS or something, you have a lot of different packages in your dependencies that require the same thing. So if something else requires Symfony in version 3.1, well, we have the same problem again, that my patch is not, you know, it's not a number, so you can't resolve these two together. And in this case, we don't want to add this branch alias thing I explained earlier, because if you add the branch alias into your patch branch, you don't want this to be merged down in Symfony, because they don't care about your branch name there. So we have this other option there, which is aliasing it at the composer JSON level. So you say, I want this version dev my patch, but I want it to actually also be kind of the same as 3.1.0. And it will just make this mutant package with two version numbers on it. And that way it will pass the requirements if something else is requiring Symfony in version 3.1 or something like that. So that's one way to go around this issue when you fork something. Somewhat related, if you also have like packages that you own, that so things that you have access to commit to directly, and that you edit often, it can be convenient to like kind of work in the vendor directory directly. So if you install something in the vendor directory and then you want to just go and edit the files and commit directly from there, it's possible. And for that, you really want to install the packages from source. Like you want a git clone in the vendor directory, because if it's just a zip file, then you edit it. Well, the changes are kind of hard to track then. So what you can do is define this preferred install thing. And I mean, you have this preferred dist flag that we showed earlier, and there's a preferred source one as well, but that then clones everything if you pass that. So it can be quite slow, because you do git clones for every single dependency. But with this, the config, you can really set it per package or even per vendor with the wildcard. And so you can say, okay, like all our company stuff, we want to clone it by default, so that we can go and edit it, and then the rest can be installed from zip files. All right, so moving onwards, different types of this. So there's this concept of a composer repository, which is actually not really just one thing, because historical reasons we kind of kept adding features and features on top of it, mostly for packages.org, because it kept growing and we had to kind of make it scale a little bit. So the first version was the Satis model, which is very simple. It's just one JSON file with a list of all the packages in it. And you can see that this doesn't scale very far when you have 200,000 packages. That's not gonna happen. Because you end up downloading, I don't know, 2 gigabytes of JSON before you can resolve the dependencies. The memory issues in that case would be way worse than what we have right now. So I mean, this is still used by Satis, and it's okay if you have only a small set of packages. Then we have the packages.org model, which is a bit more complicated, or quite a bit more complicated at this point, where we have these providers. And so the first file you download is actually just a list of providers. And these are lists of packages, and they also contain these hashes. So thanks to all the hashes we have there, we can do cache invalidation pretty quickly. So if anything changes in a package, then the listing, the hash in the listing file in one of these provider files will change. And then that means the hash of the listing itself will change as well in this first file. And so by just downloading this one file, we can know in the local cache if the metadata you have is already up to date or not, and we can just go and update what's needed.
It's also the thing that allows us to actually keep this thing consistent, because here you end up with downloading quite a few different files. So what could happen, because there's 200,000 packages out there, people are pushing code all the time, that while you're downloading, you're downloading the first file, and then a new version gets pushed, and then you're downloading the second file, or just a new commit gets made to one of these packages. So the second file gets changed after you download the first one. So splitting this up into multiple files actually ends up resulting in problems as you're trying to download this metadata, because it becomes inconsistent. So the hashes actually allow us to make sure that once you've downloaded the first file, contains some of the hashes, you can download specifically the version of the other file that matches this first file. So through that, it actually allows us to kind of download a set of files that all fit together correctly.
All right. And then we have the newest model, which is for private packages, which is kind of similar to Satis in that it's only a long list of packages, because we know exactly which packages you're using, including the open source ones. We actually, we can give you a subset of data that fits your project. So we don't give you too much data anyway, and you get it all in one download file, which is much faster than downloading many files. And the other notable difference there is that we have this mirrors thing. And that allows us to mirror the dist files. So all the zip files are actually mirrored on our website, and that means if GitHub is down, for example, you can still download it from us. And if we are down, you can download it from GitHub. That way, you get redundancy at the zip file level. then, so that's kind of where it fits in, like the private packages model. So let's say if you have a VCS repository, so if you have private packages, typically you would put them in as a VCS repository. The problem is, like, what happens then is when you do a composer update, it needs the metadata. So it has to do a git clone, like from Bitbucket or wherever, or using the API. It's also like doing a lot of API requests. Like both of these are kind of slow because we need to read all the metadata to know all the versions to then do the dependency resolution. Then we install and then we do a git clone again or do zip download, and so we end up doing a lot of redundant stuff there, and it tends to be pretty slow with VCS repositories inlined in the composer JSON. And so private packages kind of sit there in the middle where we do the git clones in the background and like sync all the metadata in the background. And when you do an update, you directly get the JSON data from us, and that happens instantly. Like you get one file with everything instead of having to go and iterate through all the branches and so on. So the update part is made much faster with that.
My last section of this was that part of dependency change management is analyzing and reducing risks. So with all this information, we can kind of look at these steps again and kind of see what kinds of risks are there and how do we work with them. So the most basic one, I think, is availability, which basically just means, is the package available for download or not? Is my external service available to be connected to, and so on? So that affects this assembly stage, right? Something isn't available, like with software, this is really straightforward. If an open source library, this is a really famous case, I guess, in the JavaScript world, where somebody deleted an open source library that was used by pretty much every other JavaScript project out there. And suddenly nobody could install their projects anymore. Nobody could deploy their applications anymore. It was all failing. Because everybody was dependent on this thing and somebody had just deleted it. So that's a really easy case of thing is not available, assembly doesn't work anymore, I can't put my application together anymore. There's other examples of this, more like when we think of APIs and services again, like if you have like some kind of payment service, for example, that you're using on a shop or something, that thing is not available, can't take any payment, right? It doesn't let you connect to it. Your application stops working. Or like a favorite of mine is if you've ever worked with this VAT identification service that the European Union provides. So it's like this API where you can verify that a VAT ID a company sends you for your payment purposes works correct. This thing, I feel like it's down roughly a day out of the week. Like it's really like not the most reliable service I've ever worked with. So that too, like the thing doesn't work, like your application can't, like this is part of your application, all these external things that are part of what you're accessing, like the software as much as any of the external APIs. Or like thinking more about build time, if you use something like a local Jenkins or have some external service like a Travis CI, one of those isn't available, again, you can't put your application together. So there's quite a few different parts that all have to come together for the entirety of your application to actually work right. So things you can do to reduce this, I'll focus on the software here, like we were talking about Composer. It's really straightforward, you need to have a copy of the software to be able to install it. So if somebody deletes something, where do you have a copy? So Composer has a cache. We mentioned this earlier because it's important for speeding up your builds. In the .composer/cache directory. So if some file can't be downloaded anymore, you could try and see if you've installed it previously and try and recover it from there to then maybe do like a package definition yourself. Of course, that's not really what it's meant for. So it's more like a worst case scenario. It's good to know that this exists and this is maybe a place to look for it. What I've seen quite a few companies do is they decide to fork every single open source dependency that they have. Now this will solve the problem of availability because you have a copy of each one of your dependencies, but that also means that suddenly you have to maintain a couple hundred repositories of code that's not your own, and every time somebody updates something there, you have to update it on your repository, and like the amount of work involved in this is kind of insane. And that's really part of why something like private packages and like Status originally help you, because they make sure that you actually have a copy available that's just yours. so that you're not that dependent on some external service. It's kind of important to understand here that packages.org, it just provides the metadata. All the downloads in the end, they come from like other locations, like whatever the maintainer decided. So in 99% cases, I think that's GitHub at this point for open source libraries. Maybe that's changing with the recent announcements. I think people are like moving around. And one thing to keep in mind there is that if you're installing these dependencies, they're being downloaded from this external location. So if that thing happens to be the Subversion server hosted in the basement of some open source developer, if that thing doesn't have power right now, I can't install my application. So just for, there's something to keep in mind as you're deciding to use a dependency. So that's why something like private packages for status may be helpful. So the second part of this looks very similar to the previous image is what private packages there does is for open source dependency. Unlike your own thing that you have hosted, let's say on Bitbucket, I think was the example, you may have something from packages.org. This is the packages.org logo, which already similarly provides just JSON information. So the composer updates step is a lot faster than having to use the individual repositories, but the downloads still come directly from those locations. So with private packages, again, it sits in the middle so that both the information from packages.org gets mirrored onto there, so it has a copy of that metadata and can send it together with all the information about your private repositories where you have your own code. And then the downloads too, it generated the zip files for each version to make that a lot faster and more reliable. So the way that this ends up working is if you take a look at the log file, which usually is just a lot of information. It's not something you want to really review on a regular basis. But the interesting bit here is that it doesn't just specify the URL. In this case, there's a package from GitHub for the zip and the Git repository. But with private packages, it adds a mirrors definition so that it knows all of these URLs. It doesn't delete those. So that kind of like what Jordi was saying earlier, it can either go here to download this, or if this is not available, it can go to these original locations. You kind of get this redundancy. And because this is in the composer.log file on your local machine, you're not dependent on any of these services as you're doing this. Another part of risk reduction, like if you're adding new dependencies, I think it's kind of important to have I guess like a checklist in a sense of quality criteria as you're picking these. Like we've been talking about the size of this, right? There's some 185,000 packages out there now. They can't all be really good quality code. That's just impossible at that size. So what are criteria that you can look at to try and figure out whether or not it's a good idea to add a dependency? I think things to look at is like the number of maintainers. Is it just a single person kind of maintaining? Is there a large number of people maintaining this? Is it something that's being actively developed? Are people still contributing to this thing, or has everybody forgotten that this existed? How many users does something have? Like packages can be a little helpful here just because it shows installation counts. Don't read too much into this because the absolute numbers there is mostly just automation tools running them up. But you can tell if something has 0 installs or quite a lot of them. Or like where is the library being installed from? That's kind of what I said earlier. Do I want to use this thing that's hosted on some really unreliable place somewhere? Or like other alternatives. I mean, obviously I always try and see what are all the options if I'm trying to pick a new library that does something for me, other alternatives maybe. Which one of them do I want to rather use? And then also how easy would it be to replace this? Like if this thing stopped being maintained, would it be easy for me to switch it out for something else? Or would, was it so complex that would be nearly impossible? Or maybe, if there's not a lot of maintenance going on, would I be able to maintain it myself? And complexity is an interesting question there because on one side, if I have a really complex library, it probably does something really complicated for me, so it helps me a lot. But it also means that if I'm not really sure it's going to be maintained in the long run and I may have to do bug fixes in there myself, maybe it's not that great because now I have to understand this entire complexity. So it's kind of all of these are trade-offs, right? There are libraries that are maintained by a single person that are just really great libraries, and that's perfectly fine. There isn't like this isn't a yes or no answer, right? It's something to consider all the different factors and try to make a balanced decision. Or there are things that are just not being actively developed anymore because they just work. Like it's a small library that just does one job really well. That's fine too. So you kind of have to kind of look at all these different factors every single time that you add a new dependency. We kind of talked about this in the first talk. I just want to mention this here again in the context of this risk reduction thing. Is just compatibility, semantic versioning. I'm not going to go into the details of this again because it's the same as in the first talk. It's one of these tools that helps you make sure that as you run a composer update and so on, things are going to continue to work. There's other ways of working with, like trying to improve compatibility or testing that compatibility is not broken. Sure, like any automated tests you will have will help you with that. Or there are like static analysis tools for PHP, or we just Google for like PHP static analysis. There's quite a few that will come up that can help you tell, or they can tell you that after this update, now there's a function call somewhere that calls a function that no longer exists or something like that, or that uses an argument that is now of a different type. And there's manual things that you should do. You should actually go through when you're updating your dependencies and read the change logs. You know, we've been talking quite a bit about writing change logs and making sure that these things are documented. But the other thing is to actually read them. Like I'm curious here, who here actually before they, you know, update plugins, update packages, goes and reads all the changes that were made in them. It's like, yeah, like 2-3 hands. So please, more of you, you know, if you're updating it, try and figure out what's actually going to happen, because otherwise you don't really know if things are going to continue to work or not. This, of course, means that people have to write changelogs in a way that you can quickly like see the important changes. So it's kind of like a two-sided thing that needs to happen there. And then one thing is a bit of an experience. If you see that certain libraries really don't follow Zemver, which does happen, then, you know, maybe just use like different of the version constraints. You know, instead of this caret operator we had earlier, maybe pick like a more precise version, like a smaller version range, because you know they're likely to break things again. And then look at this particular one in more detail when you want to update it, because you've made this experience with them before. One other thing I just want to briefly mention that I guess as developers we like to often overlook a bit is legal issues, compliance issues. So this too is kind of an important thing when picking a library, but also during updates. So, you know, if you're building an application, for example, that where you're shipping the code, like depending on what your company decides they're like, what is okay. Maybe like some libraries not actually be allowed to use based on the current context that you're using there. Or the other way around, maybe you have to make some changes to your own licensing, right? Like maybe the version of the number, like the version number of the license doesn't really match with what you're using in some other library. So Composer actually has a command to help you with this called Composer Licenses, which will list the licenses of all the dependencies that you have so that you can review this. And Private Packages has something very similar, the license review, which does this across your entire organization, so like across all the different projects that you have. And licenses can change during updates, so that's something to kind of keep in mind as well. So I think my overall point with this whole like risk reduction thing is more that I think you should have a plan B, right? If you start using things, kind of think about what would happen if this thing wasn't updated anymore, and try and identify which problems are actually probable and will have great effects, because dependencies overall, they're great, right? You want to use a lot of them because you can't possibly do all that work yourself, right? So do use a lot of plugins, like use open source tools to build all these things together. But just spend like a couple minutes at some point to think about, you know, what would my approach be if this and that happens? And if your decision is to say, that's okay, it's so unlikely to happen anyways, I'll deal with it when it comes, that's an acceptable plan B. I just kind of want to point out that maybe these things are something you should keep in mind and not be entirely surprised when one day this one open source package gets deleted, that your installation, you know, that your Composer install doesn't work anymore. And, you know, it's kind of up to you to figure out which of these risks are important enough for you to actually spend any resources on, and whether that's something that's worth your time or not. And yeah, so just lastly, I guess, how's Private Packages helping with this? It basically makes Composer operations faster, the install and update, because you don't have to do the whole clone every single time. You kind of work with private dependencies a little more effectively because you get the automatic synchronization with GitHub, Bitbucket, GitLab, with like authentication. You can get different authentication tokens for each of your customers so that you can kind of set up different sets of packages that they have access to. And you end up with one central place that you have all of your own dependencies and not just all the dependencies of the open source world. And yeah, we're definitely looking forward to building some more tools around this. And with that, thank you very much. Do take a look at this, and let's do a round of questions, because I think this time we left a bunch of time so we can discuss all your composer questions, comments. Feel free. Thank you.
Thanks. So yeah, we have 15 minutes if you have anything. You can also ask in German if it helps.
We'll understand.
Nothing?
Too much all at once? Yeah, so the question is, are the private packages mirrored on packages.com too? So I think there's two things to like a distinction there. What we call mirroring is really this: there's another composer repository out there that already has the packages on there. So that's why we say that's what happens for open source packages. For the private packages, this works differently because it connects directly to wherever your Git repository is. So rather than go into packages.org to get this, it connects to there. It does keep a copy of those packages as well, so that again, you have this redundancy if you're storing them in GitHub, if GitHub is not available right now, or if you're storing them in GitLab and GitLab doesn't respond right now, it downloads it from packages.com and vice versa. So the zip files, it always has a copy of all the packages that you use in your company. We only call one of these processes mirroring. I guess that's kind of the distinction. Sure. Like other Git things, don't be shy. Complaints. Yeah, oh yeah. For private packages? Yeah, so it's a per user developer based thing at 14 euros a month, kind of similar to other developer tools, which is only, it's kind of like a smaller user number usually than your other tools, because it's only for the people who actually actively use this thing to like run composer things. Sure, in the back. Like, as in like a developer who actually works with the thing, like a user. Because the main thing is, I mean, you need to authenticate yourself, right? The whole thing is about private. So we know who has authenticated, and each user who authenticates, that's a user. Right. If you're one user, like, I'm not sure. Like, I mean, a user is a person. I don't. Sorry, I'm not really. Okay.
Kind of developer would be more accurate than user, I guess.
Yeah, I guess. Okay. Cool. Yeah.
Okay. Well, I'm not sure what more to say than.
I'll go back to the slide that we had earlier. Where was that? Here.
Yeah.
I mean, I guess the main thing is just that you can keep all these things in a single project, and you still have requirements defined between the different packages. So like in this first thing, and it just uses the symlink instead of like downloading the file or like making it available there. So it works exactly the same way as all the other dependencies, and any dependencies that you specify in the second one are also installed properly, because it's really just a regular package. The only difference is that instead of downloading it from something like packages, through downloading it from GitHub or something like that, it just creates a symlink to this other directory. I think it's really that straightforward.
Yeah, that's true. Yeah, we do have an option, but I'm not sure how easy it is. Like, you would have to change it in the composer JSON, I think, before you build, no? Oh, that's true.
You can override it with the environment variable. Yeah.
You're right. Too many environment variables. I lose track.
But honestly, I think in most cases, that's not even that necessary. I mean, I think usually if it's like one application you're working on, you kind of end up with the whole thing as one tree in CI as well.
Yeah, I think it depends how you deploy and like how many of those applications you have. Like if you have 20 websites and you want to deploy them individually, or also depends how you package, because some things don't really like symlinks too much.
Yeah,
like,
true.
So yeah, it's an option for sure to do mirroring instead of symlinking. But then yeah, for development that doesn't help a lot.
All the way in the back.
Yes.
Sorry, private packages or private packagist? Ah, okay, that's why I'm asking.
Well, it's just a repository, so you can have multiple repositories. Like
so similar to this, I mean, it's a composer repository, right? So you can just list any number of URLs that you want to list. And if they happen to provide the same name of a package, they go in order of they're preferred in the order that you're listing them in your composer.json file.
Top down, kind of the first one to provide something will be.
That said, that's really not the use case for private packages. Usually you want to have your company's, your one private packages repository that all your packages are inside of, that everything is mirrored through. So if you want to use other external packages, you mirror them into your private packages repository. Like you don't specify multiple private packages repositories in your composer.json, but you go into private packages and you add mirrors for the other external sources of packages. So that in your composer.json, you only ever have a single repository listed. That's kind of how private packages is supposed to be used. Sure. So, I mean, that's something that we offer too, like a winners option where you can set, like you can use private packages to hand out authentication tokens. But if you're just using, like if you don't have a private packages account yourself, but you just have, you just bought packages from people using private packages, then you can just list all these URLs that they've given you in your composer.json. If you have a private packages account yourself, you can just add all these different sources to your private packages account. But so yes, if you just get a URL for like specific packages that you've purchased from somebody, so that's something that private packages makes possible because it does this whole authentication mechanism. You can just list all of them in your composer.json file. I think the Contao manager questions aren't really that well directed as us.
No, but yeah. I think we have to talk to Andreas again later.
I mean, I think in some way there's some of the technology to make this possible in Composer sort of available, but there's definitely work needed around this kind of thing to actually make anything like this happen.
It was about integrating like this selling of packages into the manager.
Yeah, exactly. That's basically his question, is if that's moved further since last year, like, and how far there's new developments on that. That was his question. I was like, and we're not really the right people to answer that. Yeah. Yeah.
Okay. Well, we're ready. So now it's up to you. Okay.
So yeah, there will be more discussion about this, but it's not quite there yet. All right. Any more questions? Otherwise, like I said, we'll be around for the rest of the conference. So do find us. If you want some Composer stickers.
Oh yeah, we have stickers.
Come to us.
And I had also one question for the locals. I don't know. Where is it? There. I was just wondering which ones are the best. If anyone is actually from Salzburg, I don't know. Yeah, okay.
Sure, so the first one there.
I read it's the original. Yeah, they even have the original domain, like the original.com or something like that. So, okay. Well, thank you. Anyway.